So now we're moving on to ratios and conversions. And the first problem in this section has to do with comparing unit rates. So the question is, you're shopping for t-shirts. Which store offers the best deal? Store A, you can get 2 shirts for $25. At store B, you can get 4 shirts for $45. And at store C, you can get 3 shirts for $30. So where is your money going to go furthest? What we're going to do is we're going to divide the price by the number of shirts that you can get. So at store A, you can get 2 shirts for $25. 25 divided by 2 is going to be $12.50 per shirt. At store B, you can get 4 shirts for $45, so we're going to do $45 divided by 4, and that comes out to $11.25. So as of right now, store B is the better deal. Now store C has 3 shirts for $30, so we divide 30 by 3. That gives us $10 per shirt. So if we want the store with the lowest price, store C is going to be where we're going to go. In problem number 2, we're going to convert units, and we're going to find out what is the given amount converted to the given units. And we have 330 minutes to how many hours? So we establish what is the original unit. The original unit is 330 minutes. And then we're going to establish how many of the original units are in the new unit. So how many minutes are in 1 hour? There's 60. Since we're going from smaller to larger units, we're going to divide the original by the new. So 330 divided by 60 is 5 and 30 over 60. We reduce that to 5 1/2 hours, or we can say 5.5 hours. Since we're dealing with time, you can leave your answer as a mixed number or as a decimal. In part B, we're dealing with kilograms to grams. So we want to know if we are converting from 15 kilograms, how many grams will there be? So 15 kilograms is our original unit. There are 1,000 grams in 1 kilogram. Since we're going from a heavier to a lighter measurement, we're going to multiply the original by the new. So that's going to be 15 times 1,000, or 15,000 grams. In C, we're going to change 5 feet 3 inches to inches. So the original unit is 5 feet and 3 inches. We need to establish how many of the original units are in the new unit. So there's 12 inches in 1 foot. So we're going to do 5 times 12 because we have 5 full feet. It's going to give us 60 inches, plus the 3 that we already had, that gives us 63 inches. In problem number 3, we're going to convert units between systems, specifically the imperial system, which is still in use in the United States, and the metric system, which is in use in most of the world. So the CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower, round to the nearest meter? Use the fact that 1 meter is approximately 3.28 feet. So again, establish the original unit of 1,815 feet. We need to know how many of the new units are in the original unit. So there's 3.28 feet in 1 meter. Since we're going from a shorter to a longer measurement, we're going to divide the original by the new. So we're going to do 1815 divided by 3.28, and that's going to give us approximately 533 meters. So that's how tall the CN Tower in Toronto is in meters. In problem number 4, we're going to convert rates. This question is going to be a little bit more complicated. It's going to take a few steps to be able to get to the solution. The question is, a student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. So the first thing that we're going to do here is we're going to set up a proportion. We're going to go yards run over time in seconds equals the yards in a mile over the time in seconds for a mile. Then we're going to substitute the known values into that proportion. So we're going to go 50 over 5.8 equals 1760 over x. The 1760 is the yards in a mile. Cross multiply, we get 50 times x equals 50x, and 5.8 times 1760 equals 10,208. At this point, we isolate the variable. So x equals 204.16 seconds, and that's the number of seconds it takes to run 1 mile. There are 3,600 seconds in 1 hour, because you have 60 seconds in a minute and 60 minutes in an hour. So we're going to go 3,600 seconds divided by the 204.16 seconds that it takes to run 1 mile. That's going to give us the miles per hour. So we do that and we find out that the approximate speed was 17.6 miles per hour.